Need to authenticate with an MCP server, but unsure whether to use OAuth, bearer tokens, or custom headers? We'll demonstrate the simplest OAuth setup using FastMCP's built-in helper, while clarifying that production use requires additional configuration like client credentials and token storage. The example shows how the same Async context manager pattern works across all auth methods, from basic OAuth initialization to full auth 0 integration with encrypted token storage. From FastMCP import client. From FastMCP client auth import OAuth. OAuth equals OAuth. MCP URL equals https://fastmcp cloud/mcp. Async with client. https://fastmcp cloud/mcp. Auth equals OAuth as client. Await client ping. This demonstrates the configurable authentication strategy pattern, where FastMCP supports multiple interchangeable authentication methods through a unified client interface. The framework abstracts authentication details behind a consistent auth parameter, allowing you to switch between OAuth flows, bearer tokens, or custom headers without modifying core application logic. The key distinction is that authentication becomes a pluggable component rather than hard-coded behavior, with the client handling protocol specifics based on the provided configuration. The pattern works by treating authentication as a first-class configuration concern, where different auth methods implement the same interface but handle their respective flows internally. When you initialize the client with an OAuth instance, a bearer token string, or custom headers, the framework automatically manages the authentication lifecycle, including token acquisition, refresh cycles, and request signing within the Async context. This design keeps your application code focused on its domain logic, while the framework handles transport-level security, with the context manager ensuring proper resource cleanup regardless of the auth method used. This approach matters because it provides production-grade flexibility without sacrificing simplicity for basic use cases. The same ping call works identically whether using a full OAuth flow with PKCE, a static bearer token, or custom headers, while still allowing for complex scenarios like encrypted token storage or dynamic client registration when needed. The trade-off is that while simple cases require minimal setup, production OAuth implementations need additional configuration for client credentials, token storage backends, and server metadata, all of which remain cleanly separated from your application's core functionality. Let's break it down line by line. From FastMCP import client. This imports the client class, FastMCP's primary interface for server communication that works with multiple authentication schemes. The client handles connection management, protocol serialization, and request response cycles while delegating authentication to pluggable providers like OAuth, bearerauth, or custom headers. While this example shows minimal OAuth initialization with just a URL, production implementations require additional configuration, cliented, client secret, token storage, and often use the full auth 0 provider setup with Redis store for token management. The same client works identically with bearerauth or custom headers when properly configured. From FastMCP client auth import OAuth. This imports FastMCP's OAuth class for token-based authentication, one of 3 supported auth methods alongside bearerauth and custom headers. The example shows minimal initialization with just MCP URL, but production use requires additional parameters like cliented and client secret, plus token storage configuration. For complete OAuth flows, you'd configure an auth 0 provider with token storage, like Redis store and refresh logic. This simplified example omits those details for clarity. The same context manager pattern works identically with all auth methods. OAuth equals OAuth. MCP URL equals https://FastMCP cloud/MCP. Initializes OAuth authentication with just the MCP server URL, showing the minimal configuration pattern. In production, you'd need additional parameters like cliented and client secret, typically configured through Auth0 provider with token storage like RIDI store. This pattern keeps authentication separate from business logic, and the same context manager handles connection lifecycle regardless of whether you use OAuth, bearer auth, or custom headers. Async with client, https://FastMCP cloud/MCP auth equals OAuth as client. Establishes an authenticated FastMCP connection using Python's Async context manager pattern. The auth equals OAuth parameter demonstrates one of three supported authentication approaches: OAuth, bearer tokens, or custom headers. With this example showing the minimal OAuth initialization that would require additional configuration, client credentials, token storage, and refresh logic in production. The context manager ensures proper connection lifecycle management regardless of authentication method, while the ping operation serves as a basic health check that works identically across all auth strategies. Await client ping. Sends a lightweight health check to verify the connection works with the configured authentication. This ping call confirms both network connectivity and that your chosen auth method, OAuth, bearer auth, or custom headers, is properly configured before making real API calls. The example shows OAuth initialization in its simplest form, but production setups require additional parameters like cliented and client secret, plus token storage configuration. The context manager ensures proper connection cleanup regardless of which auth method you use. FastMCP authentication patterns. This code demonstrates the minimal OAuth initialization pattern, where the client context manager abstracts connection lifecycle and authentication handling across multiple supported methods. Bearer auth tokens, custom headers, and OAuth flows all work interchangeably with the same ping, connectivity check, and async context management.
The authentication method that disappears into the context manager becomes all authentication methods.